Hello and welcome to today's class. My name is Dr. Wanjala Titus. Today I will be taking you through statistics and probability, and today we are going to look at the gamma distribution. Under the gamma distribution, we are going to look at the probability density function of a gamma distribution. The probability density function of a gamma distribution is always given by beta raised to alpha, gamma alpha, x raised to alpha minus 1 exponent x negative x beta for x running from 1 all the way to infinity. If you haven't subscribed in my channel, please take a second, you subscribe so that in case of any information, you'll be the first one to be notified. Therefore, let us look at the questions that you might interact in an exam. You'll find a question asking you to derive the mean and variance of a gamma distribution. And therefore, since a gamma distribution is a continuous random variable, then since it's continuous random variable, then the mean or the expected value of x will be given as the integral from 0 all the way to infinity, from 0 all the way to infinity, then x probability mass function dx. That's how we derive the mean. Now let us replace the variables, the values, and we see the integral from 0 all the way to infinity. We have x, but our probability density function is beta raised to alpha out of gamma alpha. We have x alpha minus 1 exponent x beta dx. And therefore, as we can see, this sample here is our constant. So we can remove it out of the bracket so that for easier simplification. So this one, it will be beta alpha out of gamma alpha, the integral of from 0 all the way to infinity. We have x raised to 2 power 1, but it will be, when we combine this one and this one, it will be alpha plus 1 minus 1 exponent negative x beta dx. That's how easier it is. Therefore, what are we going to do next? What we are going to do, this under the simplification of this, when we derive this one, it will give us the whole of this one will give us beta alpha plus 1 gamma alpha plus 1 out of beta alpha plus 1. Are you getting it? It will give us gamma alpha plus 1 out of beta alpha plus 1. So what do we do? It will be beta alpha out of gamma alpha, then we multiply by this one, which is gamma alpha plus 1 out of beta alpha plus 1. So what do we need to do is we have to rewrite this one in simple ways and this one in a simple way, so that for easier simplification. So it will be beta alpha, then we have gamma alpha, but when we simplify this one, it will be alpha, the root of or the gamma alpha. This one can be easily written by this one. Then this one can also be written as beta alpha multiplied by beta power 1, laws of indices. This one and this one is just the same as this one. So this one cancels out this one cancels out this one. So our expected value of x will give us alpha out of beta. That's how we derive the expected value of x from a gamma distribution. So what are we going to do next? What do we do next is to derive variance of x. Variance, as we all know, variance of x is equals to the expected value of x squared minus the expected value of x. But this one is squared. So what do? We have to find this one squared, the square of this one. So the square of this one, x squared, is equals to the integral from 0 all the way to infinity. We have x squared f of x dx. That's how we do it. So in reaching there, what do? We say it will be the integral from 0 all the way to infinity, x squared. Our probability density function is beta alpha gamma alpha x alpha minus 1 exponent negative beta x beta dx. That's how we do it. But this one always is our constant. It will be beta alpha out of gamma alpha. Then we have the integral from 0 all the way to infinity. Then we have, it will be x raised to alpha plus 2 minus 1. Are we getting it? Then we have exponent negative x beta dx. That's how we do it. Then what are we going to do next? All of this one will always give us gamma alpha plus 2 out of beta alpha plus 2. The whole of this one will give us this. So we automatically multiply the two. So this one is going to be beta alpha out of gamma alpha. We multiply by gamma alpha plus 2 out of beta alpha plus 2. Then what should we do next? What are we going to do next? So we have to rewrite this one, also the sum of this one, to be in a simple way for easier simplification. So it will be beta alpha out of gamma alpha, then we multiply. When we simplify this one, it will be alpha plus 1 alpha gamma alpha. This one can be written as this one, all over. When we simplify this one, it will be beta alpha. Are we getting it? Beta alpha. Then we have beta raised to power 2. Then this one will cancel out this one. This one will cancel out this one. So the expected value of x squared, it will be alpha squared plus alpha out of beta squared. But what do we say the variance? Variance, we said we find the expected value of x squared minus the mean, which is x, expected value of x. So what are we going to do? We take this one, we subtract from the mean, which is this one. So it will be alpha squared plus alpha out of beta squared minus alpha, but we have to square, out of beta squared. The LCM, we find the LCM. The LCM will just remain as beta squared. We take this one, multiply with this one is 1, which is multiplied by this one, to gives us alpha squared plus alpha minus alpha squared. So this one cancels out this one. Then we remain with the variance of x being equals to alpha out of beta squared. That's how we derive the variance. Hope you have enjoyed your lesson. Keep for watching. Thanks for watching. Subscribe in my channel for more information. Thank you and bye bye.